We'll now use completing the square method for finding solutions of quadratic equation. Here the given quadratic equation is t square plus 8t plus 15 is equal to 0. So let's get started. Given equation is t square plus 8t plus 15 equal to 0, and we'll compare it with the standard form. Comparing with standard form, we have at square plus bt plus c is equal to 0. Just by changing the variable x with t, we have this as standard form, and from equation 1 and 2 what we get is a equal to 1 because the coefficient of t square is 1 here, and coefficient of t is 8, therefore b is equal to 8 and c is equal to 15. It is important that we have a is equal to 1 always. If a is not equal to 1, then we divide the entire equation to make it a is equal to 1. Therefore, t square plus 8t plus 15, it's good to go because a in this case is already equal to 1. So this is good to go equation. And now we are going to, for step 1, we are going to move the constant term which is 15 on the right hand side. So step 1, move the constant term on right hand side, and this way we get t square plus 8t equal to minus 15. And once we have moved the constant term on the right hand side, and we already have made sure that the coefficient of t square is 1, now in this rough area write the coefficient of t. So coefficient of t is plus 8, just multiply it with 1 over 2. What we get in the answer is plus 4. So adding plus 4 whole square on both sides and taking the square, so this will be adding plus 4 whole square on both sides of the equation, So this will give us t square plus 8t plus 4 square, and what is on the other side is minus 15 plus 4 square, because same thing we are going to add on both sides of the equation. And if you take a look on this formula, a square plus 2ab plus b square, this is equal to a plus b whole square. We have this formula from algebra, and that is at display in this case on left hand side. It is a square term is t and then the plus 4 square. So left hand side is whole square of t plus 4, both of the sum of both of the square terms. Whole square is equal to minus 15 plus 4 square is 16. So this is equal to t plus 4 square is equal to 1, and t plus 4 is equal to plus minus 1 square root, which is 1 again. This is t equal to minus 4 plus minus 1. So t is 1 time minus 4 plus 1, and 1 time it's minus 4 minus 1. Therefore, the two values of t are minus 3 and minus 5. These are the two possible values for t, and we can verify the results as well. Verification at t is equal to minus 3. What was the equation? Equation was t squared plus 8t plus 15 equal to 0. We can see that this will become minus 3 squared plus 8 times minus 3 plus 15 equal to 0. This means 9 minus 24 plus 15 equal to 0. And here we have 24 minus 24 equal to 0, means 0 equal to 0. Therefore, the solution also has been verified, and similarly you can do for the other value of t. Similarly verify for t is equal to minus 5. Now let's do one more question, and this time we have is example number 2. In this example, the given equation is x squared minus x minus 1806 equal to 0. The constant term is pretty big, but that's fine. We'll use completing the square method to find solution of this quadratic equation. And before we get started, we have to make sure that the coefficient of x squared is 1. If it was not 1, then we will divide the entire equation with whatever coefficient would be there. So if it was 2x squared, then we'll divide the entire equation with 2 in order to get the coefficient of x squared equal to 1. So we have x squared minus x, and let's move the constant term on the other side. That will become 1806, and in rough area write coefficient of x. So coefficient of x, which is equal to minus 1, and we multiply it with 1 by 2 always. That's the procedure. That's minus 1 by 2, and whatever you get, take the square and add this number on both sides of the equation. Adding minus 1 by 2 square on both sides of equation. This will give us x squared minus x plus minus 1 by 2 square equal to 1806 plus minus 1 by 2 squared. Same thing we have to add on both sides of the equation. And like we learned before, just take a look on both the square term. One is x, the other one is minus 1 by 2, and their sum is x minus 1 by 2, and left hand side is whole square of x and minus 1 by 2. This is equal to 1806 plus 1 over 4. And if you take LCM on right hand side, this will become 4, and we'll have to multiply 1806 times 4 plus 1, and on left side this is x minus 1 by 2 whole square. So we get x minus 1 by 2 whole square equal to 1806 times 4 will give us 7224, and plus 1, this will be 7225 divided by 4. And now, just like square root property we learned in method 1, that was x minus 1 by 2 whole square, we take square root, this will become equal to plus minus square root of 7225 divided by 4. And if we take square root of 7225, that would be equal to x minus 1 by 2 equal to plus minus, this is equal to 85 over 2. So that is square root. 85 is the square root of 7225 and 2 is the square root of 4. So x is equal to 1 by 2 plus minus 85 divided by 2, and one time we are going to take positive sign, that is 1 by 2 plus 85 over 2, and one time we are going to take negative. For that, x is equal to 1 by 2 minus 85 over 2. So if this is the case, then this is 86 by 2, and if this is the case, x is equal to minus 84 by 2. So here this is x equal to 4 and 3, and here x is equal to minus 4 and 2. So these are the two values of x for which we employed the square completing method, and we got the solution for the given quadratic equation. Let's derive a formula by completing the square on the general equation. So example number 3, to find solution of ax square plus bx plus c equal to 0, which is a general form, we first have to divide entire equation by a. I explained that in question 1 as well as question number 2, that if coefficient of x square is anything other than 1, we have to divide the entire equation by that coefficient. Here it is a. So dividing entire equation by a, this would give us ax square over a plus b over ax plus c over a equal to 0 over a, that is equal to 0. This was the first thing, and here we got x square, the coefficient of x square obviously is equal to 1 now, plus b over a x, and we know that we have to move the constant term on the right hand side, so this would be minus c over a. In rough area, what we do is we write the coefficient of x, which is plus b over a, as part of our procedure, and then multiply it with 1 by 2. Whatever number we get, that is plus b over 2a, we take its square and add on both sides of equation, adding plus b over 2a on both sides of equation. What we get is here x square, so this will become x square plus b over a x plus b over 2a square equal to minus c over a, which was already there, and plus b over 2a whole square. So on left hand side, this is the equation that we get is a full square of x plus b over 2a whole square equal to, this would be b square over 4a square minus c over a. And let's first simplify this before applying the square root property. So this would be, LCM would be 4a square, and this is b square minus 4ac, and on the left side this is x plus b over 2a whole square. Now we apply the square root property and we get x plus b over 2a equal to plus minus square root of b square minus 4ac over 4a square, which is x equal to minus b over 2a plus minus, and here we have b square minus 4ac divided by 2a, because 4a square root is equal to 2a. On both sides we have the same denominator, therefore by taking LCM this will give us minus b plus minus, this is b square minus 4ac divided by 2a, which is solution of equation ax square plus bx plus c equal to 0, and is known as quadratic formula, and is known as quadratic formula. So this solution helps us in illustrating the general procedure that we adopt for finding the solution by completing the square, as well as it has given us the formula which from now on we'll be using directly without actual completing the square for finding solution, and that is called the quadratic formula, or the method of applying quadratic formula for finding solution.